This is Homeschool 101, a collaboration between ABS Television and the Ministry of Education. Stay attentive and attempt all activities. And now, today's lesson.
Hello everyone, welcome to Homeschooling 101. My name is Miss Henderson and I will be going through integrated mathematics with you. Today we will start off by looking at the first module, Foundations of Mathematics. We will be going through the first unit, which is numbers. And what I would encourage you to do as we go through the various classes, what I want you to do is to think about what exactly you want to learn during this class. Also, I want to encourage you to think about why this is important to you and then take the time to practice, because we know with mathematics it takes a lot of practice. So what I would encourage you to do as we go through the examples, go over your notes and practice the various examples and questions. So let us get right into it. So when we think about numbers, how are numbers used in your everyday life? Think about what you do on a daily basis and how you use numbers. As we can see, numbers are important and we use numbers in our everyday life. We use numbers when we think about date, when we think about time, when we think about the year. We use numbers when we're dealing with counting money, making various purchases. We also use numbers when we're changing the TV channel, when we're making a phone call, numbers are used. So at the end of today's lesson, you should be able to distinguish among the set of numbers. You should be able to solve problems involving the properties of complex numbers. And finally, you should be able to find complex solutions in conjugate pairs to quadratic equations which has no real solutions. So let us get right to it. In terms of classifications of numbers, numbers are classified into well-defined sets called number systems. The two number systems that we will focus on are the real number systems and the complex number systems. In terms of real numbers denoted by the symbol R, real numbers are divided into two sets, the set of irrational numbers and the set of rational numbers. And what we will do is to go through each of these individually. In terms of the set of rational numbers, the set of rational numbers refers to numbers that can be written in the form A over B. Essentially, they are numbers that can be written as a fractions. This therefore includes all our fractions, all our recurring decimals, decimals with limited number of decimal places. It includes our whole numbers and our integers. And as we can see here, rational numbers are further subdivided into three categories. We have the set of natural numbers, and the set of natural numbers speaks to our counting numbers. And how do we count? We count 1, 2, 3, and we continue. The second set that we have would be our set of whole numbers, and our whole numbers include the set of natural numbers and 0. So starting with the 0, 0, 1, 2, 3, and we continue. The final set of numbers include our integers, and these refer to our negative and positive whole numbers as well as 0. And what I want you to do also is to pay close attention to the symbols that are used to represent each. In terms of rational numbers, we use the symbol Q to represent the set of rational numbers. In terms of natural numbers, we use the symbol N. In terms of whole numbers, we use the symbol W, and in terms of integers, we use the symbol Z. Then we move on to our second set. As indicated, the set of real numbers consists of irrational and rational numbers. So we looked at the rational numbers, now we're looking at the irrational numbers. Now the irrational numbers denoted by the symbol Q, the set of irrational numbers would be those numbers that cannot be expressed as a fraction. So we said the rational numbers are those that can be expressed as a fraction. So the irrational numbers would therefore be numbers that cannot be expressed as a fraction. So if we look at the irrational numbers here, what we would see is the square root of 2, the square root of 11. Essentially, the set of irrational numbers would be the square root of our prime numbers. Once we're finding the square root of a prime number, that would be irrational. In addition, another example of irrational numbers would be pi and e, which refers to Euler's number. So, to summarize the real number system, so as indicated, the real numbers consist of two categories of numbers, irrational numbers and rational numbers. Your irrational numbers would be those that cannot be expressed as a fraction, while your rational numbers would be those that can be expressed as a fraction. Included in the set of rational numbers are three additional sets. Your set of natural numbers, which are your counting numbers, your set of whole numbers, which are your natural numbers and 0, and your set of integers, which refers to your negative and positive numbers as well as 0. So we will go through our first activity, activity 1, and it states, given that r is equal to this set, which of the following represent the set of integers? So you have a few seconds to go through. So looking at the various options A to D, determine which of these represents the set of integers. Okay. So we will go through the solution now. Right. So from the sets given, the correct answer is C. The set Z is equal to the set containing the elements -6, 0, the square root of 4, and 625. The second thing we will look at is complex numbers. So we have been looking at numbers, and we said that the number systems that we're looking at two. So the first one we looked at was the real number system, and the second one we're now looking at is a set of complex numbers. Now, the set of complex numbers denoted by C refers to numbers in the form z is equal to x plus iy, where I is equal to the square root of -1, and x and y are real numbers, and I is the imaginary unit. So when we think about complex numbers, in the standard form, x is called the real part, iy is called the imaginary part, and I square is equal to -1. We will then focus on the powers of I. And in terms of powers of I, here you will have to use a bit of knowledge of exponents, because that will be required when we're simplifying the powers of I. Now, if we look to the board over here, we have I to the power 0. Now we know that anything to the power 0 gives us a value of 1. Secondly, we have I to the power 1. And again, applying your knowledge of exponents, we know that anything raised to the power 1 is always itself. So therefore, I to the power 1 is equal to I. Thirdly, we look at I square. And we said previously that I square is equal to -1. If we look at I to the power 3, again, what we would have to do is to use our knowledge of exponents to rewrite as the product of two terms, I to a power. Now, we know that from indices, once we're multiplying and the base is the same, we simply add the powers. So once we have I to the power 3, we can separate this as I to the power 1 times I square. We know that I to the power 1 is itself, and I square is equal to -1. Therefore, if we take the product, this becomes -I. We can continue looking from I to the power 4 all the way to I to the power 8. I to the power 4 gives us a value of 1. I to the power 5, again, we separate as I to the power 1 times I to the power 4. We know that I to the power 4 gives us a value of -1. Therefore, it becomes I times -1, I times 1, which gives us I. So if we're looking at I to the power 6, this gives us -1. I to the power 7 gives us negative I, and I to the power 8 gives us 1. So as we can observe from I to the power 0 to I to the power 8, what we can see is that the pattern repeats. When it's I to the power 0, it's 1, I, negative 1, and negative I. Essentially, if we look at the values, I to the power 0 gives us 1, I to the power 4 gives us 1, and I to the power 8 gives us 1. As we can see, that is essentially I to the power 4n. 4 times 0 would give us 0, and that would give us a value of 1. 4 times 1, I to the power 4 times 1 gives us 1, and I to the power 4 times 2, which is 8, gives us 1. So essentially, whenever we are given any power of I, all we need to do is to try to write in one of these 4 options. I to the power 4n, which would give us 1, or I to the power 4n plus 1, which gives us I. And we can look to see if we have I to the power 1, it's the same thing as having I to the power 4 times 0 plus 1, which gives us I. Then we look at I to the power 5, which gives us I to the power 4 times 1 plus 1, and we continue in that pattern. Then if we look to the third option, I to the power 4n plus 2 would give us a value of negative 1, and I to the power 4n plus 3 would give us a value of negative I. So therefore, any power of I that you are given, you will be able to simplify the power by trying to write as one of these options. Either I to the power 4n, I to the power 4n plus 1, I to the power 4n plus 2, or I to the power 4n plus 3. And these will be the 4 options that you would get once you have I being raised to a positive power. So we will then look at some examples. So here I have 2 examples. So the first, I to the power 159. So what we will try to do is to write 159 as either I to the power 4n, to the power 4n plus 1, 4n plus 2, or 4n plus 3. So as we look here, we can see that I to the power 159 would be written as I to the power 4 times 39 plus 3. We know that 4 times 39 would give us 156, so it's 156 plus 3. We would then go ahead and rewrite as I to the power 4 in a bracket times 39. And we're doing this because we will make a substitution for I to the power 4. Recall that I to the power 4 is equal to positive 1. So this then becomes I to the power 4, which is 1 to the power 39 times negative I, because I to the power 3 gives us negative I. We know that 1 to any power is itself. So in this case, 1 to the power 39 would give us 1. Therefore, 1 times negative I would give us a value of negative I. Then we look to the second example. So the second example, here we see I being raised to a negative power. And once we have I being written to a negative power, what we will have to do is to use our knowledge of exponents in order to simplify, to get rid of the negative. And to get rid of the negative, we're simply using this property. A to the negative n is equal to 1 divided by a to the power n. So the first thing we would do is to rewrite I to the negative 14 as 1 divided by I to the positive 14. So we get rid of the negative by applying this property, writing it as a fraction. Now that it is in the form of a fraction, what we would need to do is to focus on the denominator and simply write the denominator as I to the 4n, 4n plus 1, 4n plus 2, or 4n plus 3. As we see, 14 is I to the power 4 times 3, which is plus 2. So essentially 14 can be 4 times 3, which gives us 12, plus 2. So once we have written it as such, we then separate 12 as I to the power 4 times I to the power 3. In a bracket times I to the power 2. So we make the substitution I to the power 4. We know that I to the power 4 gives us 1. So therefore it becomes 1 to the power 3 times negative 1 because I squared gives us negative 1. So in our denominator we have 1 times negative 1, which gives us negative 1. Therefore 1 divided by negative 1 gives us a value of negative 1. So just to recap, once we have a positive power, the results will always be either 1, negative 1, positive I, or negative I. To determine what this is, what we need to do is to try to write I as to the power, either I to the power 4n, I to the power 4n plus 1, I to the power 4n plus 2, or I to the power 4n plus 3. In the case of the second example, once I have a negative power, what I will have to do is to simplify using my knowledge of exponents. I get rid of the negative by simply writing as a fraction, and I proceed as normal. The next thing we will look at is the equality of complex numbers. And complex numbers are equal if their real parts are equal and their imaginary parts are equal. So based on what is here, given two complex numbers, a plus bi and c plus di, a plus bi is equal to c plus di if a is equal to c and b is equal to d, if their real parts are equal and their imaginary parts are also equal. We will then proceed to sums and differences of complex numbers. Now, when we think about taking the sums and differences of complex numbers, what we would need to do is to take the sum of their real parts and the sum of their imaginary parts. In the case where we're looking at the difference, we also take the difference of their real parts and the difference of their imaginary parts. Now, if we look at the examples here, so in the first example, I have 2 minus I plus 5 minus 4i. Now in this case, what are their real parts? In the first case, the real part is 2, and in the second case, in the second complex number, the real part is 5. Their imaginary parts are negative I or negative 1i and positive 4i. Therefore, if we're taking the sums, what we would need to do is to take the sums of their real parts. So it becomes 2 plus 5 plus negative 1 plus 4i. So 2 plus 5 would give us 7. That's the sum of their real parts. And to take the sum of the imaginary parts, negative 1 plus 4 would give us positive 3i. Now remember, once we're dealing with numbers of opposite signs, what we would simply do is to subtract the smaller from the larger and then rewrite the sign of the larger. Then we proceed to the second example here. We have negative 5 plus 7i minus 6 plus 4i. So again, in this case, what are their real parts? What are their imaginary parts? In terms of their real parts, for the first complex number, the real part is negative 5, and for the second, it is positive 6. In terms of their imaginary parts, for the first, it is 7i, and the second would be 4i. So again, we're taking the difference between the numbers and pay close attention to the sign that is in front of each number. In this case, we have a negative 5 minus 6. And in terms of their imaginary parts, it becomes 7 minus 4. So here we have two numbers with the same sign, and once the signs are the same, we simply take the sum of the numbers and then rewrite the sign. So therefore, negative 5 plus negative 6 would give me negative 11. And for the second part, the imaginary part, 7 minus 4 would give me 3. Therefore, the difference between these two complex numbers would be negative 11 plus 3i. So we've looked at the equality of complex numbers. We've looked at taking the sum and differences. So now we will proceed to taking the product of a complex number. And when we're dealing with the product of a complex number, It is defined so that the usual commutative and distributive law holds. Essentially, when we're dealing with a product, what we would simply do is to multiply all the elements of the second complex number by the elements of the first. So in this case, I'm multiplying the second complex number by the elements in the first. So I would simply multiply 4 times 2 plus 5i, and I'm also multiplying negative 3i times 2 plus 5i. What I simply do, I expand each bracket by multiplying by the number that is outside. So therefore, 4 times 2 would give me 8. 4 times 5i would give me 20i. Negative 3i times 2 would give me negative 6. Remember, a negative times a positive gives me a negative. Therefore, negative 3i times positive 5i gives me negative 15i squared. We group like terms and simplify, so therefore 20i minus 6i would give me positive 14i. So then I end up with 8 plus 14i minus 15i squared. But we know that I squared is equal to negative 1. Therefore, we will have to make a substitution for I squared, replacing I squared with negative 1. So this then becomes 8 plus 14i minus 15 times negative 1. Now we know that a negative times a negative would give us a positive. Therefore, the result is 8 plus 14i plus 15. We then group like terms, so 8 plus 15 would give me 23 plus 14i. Therefore, the product of these two complex numbers would be 23 plus 14i. So we'll go to an activity. So here is our second activity where we'll be looking. You have these 2 questions to complete. So what I will do, you will complete them. We will take a break so that you can complete your questions, and then we will resume in a while.
You're watching Homeschool 101.
Welcome back. Hopefully you're through doing both questions, and we will now go through the solutions. So for the first question, it states, what is I to the power 31 in its simplified form? Hopefully you would have gotten the correct answer, which is B. So I to the 31 in its simplified form would be negative I. So as we can see, I to the 31, we simply write it as I to the power 4n plus 3. So it becomes 4 times 7 plus 3. We know that I to the power 4 gives us 1. So 1 to the power 7 times I to the power 3, which is negative I. Therefore, 1 times negative I would give us a value of negative I. Then we move on to the second question. Now, the second question states, what is the product of 4 minus 3i and 5 plus 2i? So essentially, the correct answer is D, and if you got that correct, give yourself a tap. So 4 minus 3i times 5 plus 2i. So again, what we would need to do is to multiply. So we go 4 times 5 would give us 20. Then 4 times 2i would give us positive 8i. Negative 3i times 5 would give us negative 15i. And remember to pay close attention to the signs. A negative times a positive gives us a negative. Negative 3i times 2i would give us negative 6i squared. So again, we simplify the like terms. So 8i minus 15i would give us negative 7i. And in terms of I squared, remember, I squared is equal to negative 1, so we make that substitution. So it becomes 20 minus 7i plus 6, which gives us 26 minus 7i. Then we move on to the next subtopic, which is division of complex numbers. Now, to find the quotient of two complex numbers, we need to multiply the numerator and the denominator by what is called its conjugate. Now, the conjugate of a complex number, it is a number with an equal real part and an imaginary part that is equal in magnitude but opposite in signs. So therefore, when we're speaking about a complex number and its conjugate, the real parts would be equal. The imaginary parts would also be equal, except the signs are different. So in this case, given z is equal to a plus bi, the conjugate would be a is equal to minus bi. So again, a is common to both. They are the same, bi as well. The only difference is the sign, which is negative. A key thing to note, when we multiply a complex number by its conjugate, what we will end up with a real number. It's essentially the same as having a squared plus b squared. And what I want you to do is to, during your free time, just go through, multiply, do the multiplication to see that this is actually what you get. So we will look at an example here. So we have 12 minus 10i divided by 3 plus 5i. And again, what we would need to do is to simply multiply by the conjugate of the denominator. So the denominator is 3 plus 5i. So therefore, if I'm multiplying by its conjugate, the conjugate of 3 plus 5i would be 3 minus 5i. The only thing that would change would be the sign here, so that positive sign would change to a negative sign, so it becomes 3 plus 5i. So again, what I would do is to multiply both numerator and denominator by the conjugate, and we looked at multiplication, so therefore you should be able to do this. So again, what we would do is to multiply the second complex number, which is 3 minus 5i, or the conjugate, by all the terms or the elements in the first complex number. So it becomes 12 times 3 minus 5i plus negative 10i times 3 minus 5i. And in the denominator, we do the same. So it is 3 times 3 minus 5i plus 5i times 3 minus 5i. So 3 times 12 would give us 36. 12 times negative 5i would give us negative 60i. And again, pay close attention to the signs. A positive times a negative will always give us a negative. Then it becomes negative 10i times 3, which gives us negative 30i. And a negative 10i times 5i would give us positive 50i squared. But we know that I squared is equal to negative 1. Therefore, we make a substitution for I squared to be equal to negative 1. Then we look at the denominator. So 3 times 3 would give us 9. 3 times negative 5i would give us negative 15i. Positive 5i times 3 gives us positive 15i. 5i times negative 5i gives us negative 25i squared. The middle portion would disappear because negative 5i plus negative 15i, plus positive 15i, that would give us 0. So in the denominator, we would be left with 9 minus 25i squared, but we make the substitution for I squared to be negative 1. Hence, it is 9 minus 25 times negative 1. So to simplify the numerator, it becomes 36 minus 50. So again, once the signs are opposite, you subtract the smaller from the larger and rewrite the sign of the larger. So in this case, the larger is negative, hence the result, negative 14 minus 19i. And in the denominator, I have negative 25 times negative 1. Remember, a negative times a negative gives us a positive, hence it is 9 plus 25. So for the numerator, we have negative 14 minus 90i, and our denominator is 34. What we would do is to separate the real from the imaginary parts. And to separate, all we need to do is to separate the terms in the numerator and rewrite them divided by the denominator. So the real part now becomes negative 14 divided by 34, and the imaginary part becomes 90 divided by 34i. So the final answer will be negative 14 divided by 34 minus 90 over 34i. Then we looked at another way of doing this same question. Now remember, we said when we multiply the complex number by its conjugate, it gives us a real number, a squared plus b squared. So instead of going through the procedure of expanding the denominator, I can simply apply that property and rewrite the product of the complex number and its conjugate as the real number, which would be 3 squared plus 5 squared. We would still need to expand the numerator as we did previously. However, the difference would be what we do to the denominator. So in this case, if we multiply the complex number by its conjugate, essentially what we're doing is squaring the first term, or squaring the real part, plus squaring the imaginary part. So we're taking the square of the real part plus the square of the imaginary part. So 3 squared would give us 9, and 5 squared would give us 25. So therefore, the denominator becomes 34. So having simplified the numerator, we end up with the same result, which is negative 14 divided by 34 minus 90 divided by 34i. So we will go to another activity that will test your knowledge, how well you grasp the concept that we just went through. So we have 2 questions here. Find the conjugate of negative 3 minus 5i, and the second is to write 1 divided by 2 minus I in the form a plus bi. Essentially, you're dividing this complex number. So we will go to a break while you go through these questions, and then we will return.
You're watching Homeschool 101.
Welcome back. All right, so hopefully you would have completed both questions. So again, for the first question, the correct answer, negative 3 plus 5i. As indicated, we have the complex number negative 3 minus 5i. As we stated, the conjugate, it's similar, so the numbers negative 3 and 5i would be the same. However, the only difference would be in terms of the sign. So here we have a negative sign. In our conjugate, the sign would change to a positive. So as indicated, the conjugate of the complex number would be similar numbers, however different in sign for the imaginary part. Then we move on to the second example, or the second question. So it states, what is 1 divided by 2i in the form a plus bi? Now the correct answer is b, which is 2/5 plus 1/5 I. So again, the steps, what we would need to do is to multiply numerator and denominator by the conjugate of the denominator. So in this case, if the denominator is 2 minus I, our conjugate would therefore be 2 plus I, which is similar in magnitude, similar in numbers, but different in sign for the real numbers. So we simply multiply real by real and imaginary by imaginary parts. So we multiply 1 times 2 would give us 2, and 1 times I would give us I. Then for the denominator, we multiply the denominator by its conjugate, and we know once we multiply by the conjugate, we end up with a real number. So therefore, we multiply 2 times 2, which gives us 4. Then we multiply 2 times I, which would give us 2i. Then we multiply negative I times 2, which gives us negative 2i, and the negative I times I, which gives us negative I squared. If we look at this portion here, we have negative 2i plus 2i, so this would give us a value of 0. So what we're left with in the denominator is 4 minus I squared. We also know that I squared is equal to negative 1. So therefore, we make a substitution for the I squared here to give us negative 1. In the denominator, it becomes 4 minus minus 1. And we know that a negative times a negative gives us a positive. So essentially, what we will have is 4 plus 1. 4 plus 1 would give us a value of 5. Now, if we're separating in terms of our real and our imaginary parts, it becomes 2/5, which is our real part, plus 1/5 I, which gives us our imaginary part. Okay. All right, so the next thing we will look at is solving quadratic equations where the discriminant is negative. Now, we know the quadratic formula, and the quadratic formula can be used to find the roots or the solutions for a quadratic equation. So the general form of a quadratic equation would be ax squared plus bx plus c is equal to 0. Once we have that, to find x, we can use the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac divided by 2a. So what we would simply need to do is to look at the coefficients of the various terms as well as the constants and substitute in our quadratic formula. Now, a key thing to note when we will look at equations, other equations, we need to know how to differentiate between finding complex solutions as opposed to finding the solutions for a normal quadratic equations. And we will look at the discriminant, and the portion under the square root sign, which is b squared minus 4ac, this is what we call the discriminant. This is what we call the discriminant. And when we're dealing with complex solutions, b squared minus 4ac will be negative. With normal quadratic equations, b squared minus 4ac would give us a positive value. So in this case, we know that normally we can't find the square root of a negative number, because if you enter that into your calculator, you will get an error. But once we're looking at complex solutions, we can work around the negative value. So in order for us to solve quadratic equations where the discriminant is negative, what we would have to do is to replace the square root of -1 with I, because we know that when we're dealing with complex numbers, I is equal to the square root of -1. So we have an example here. So back to the question I asked her earlier. How do you know when you're told to find a complex solution or you're solving the quadratic equation normally? To know which is expected of you, what you would do is to look at the wording of the question. The question would probably say, find the complex solution to the equation, or it may say, write in the form a plus bi or x plus yi. Once the question is worded as such, you should know that you are getting a complex solution. If the question is not worded as such and it states just solve the equation, chances are you're solving a normal quadratic equation and you should not get a negative sign below. You should not get the discriminant to be negative. So let us go through. So we're using the formula x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So what we would need to do is to look for the coefficients. So in terms of a is the coefficient for my x squared term. And once a number is not there, it is given to be 1. In this case, I look at b and be careful or pay close attention to the sign, because the sign b, when I'm stating the coefficient, I must also state in terms of the sign. So I would not just state 4, but I have to state -4 because the coefficient, the sign is also negative. So I make a substitution. So in this case, it's minus b. So it becomes minus 4 because b is already negative. So once b is negative, you must have a minus. So it becomes minus 4 plus or minus the square root of -4 squared minus 4 times 1 times 5 divided by 2 times 1 because my coefficient a is 1. Recall, I'm multiplying a negative times a negative would give me a positive, hence this becomes +4 plus or minus. Key thing to note, when we square a negative number, you end up with a positive value because a negative times a negative gives us a positive. At times, if you enter -4 squared in your calculator, sometimes you may see a -16 come up. This is because what your calculator is not seeing the negative or not looking at the negative in front of the square. It is seeing it as negative and just taking 4 square. So to prevent you getting a negative value, what you may have to do is to enclose negative 4 in a bracket, then take the square, and that would give you the positive result. Because if you use negative 16, that would be incorrect. So then it becomes negative 4 times 1 times 5, which gives us negative 20. 16 minus 20 would give us negative 4. Now, once we get to here, if you try to put square root of negative 4 in your calculator, you will get an error. But what we have to do is to make a substitution for the value negative 1. So what we can simply do, think of this as the square root of 4 times negative 1, and therefore I can rewrite this as the square root of 4 times the square root of negative 1, and then I can go ahead and make the substitution for the square root of negative 1, so hence it becomes the square root of 4i. Once I have the square root of 4i, I can then go ahead and find the square root of 4. Now we know that the square root of 4 would give us 2, hence it becomes 4 plus or minus 2i. What we would do next is to then separate in terms of the real and the imaginary part. So again, once we have a fraction, we simply separate the terms in the numerator by the signs. So it becomes 4 divided by 2 plus or minus 2 divided by 2i. 4 divided by 2 would give me a value of 2. 2 divided by 2 would give me 1. So it becomes 1i. Once it is 1, we would not write the 1. All you would see is just 2 plus or minus I. This can be further separated to give us the 2x values, because once we're dealing with a quadratic, once the highest power of x is 2, it indicates that we're expecting 2 solutions. So to get the two solutions would be obtained by separating the signs. So I get one solution when I use the negative sign, and the second solution when I use the positive sign. Okay? So we have a final activity that you can complete in your spare time, finding the solutions, complex solutions to equations. So this is a question that you can complete in your spare time, and we will look at the solution at our next class.
You're watching Homeschool 101.
So we have covered quite a lot today. So we went through the classification of numbers. We looked at complex numbers in terms of the powers of i's, equality of complex numbers, sums and differences of complex numbers, as well as division of complex numbers. What I would encourage you to do is to just go back through your notes, go through various activities, so that whatever was covered, you will get a greater understanding. Well, this is it for class today. Thank you so much for joining in. I hope you learned a lot, and I will see you again at the next class.
You've been watching Homeschool 101, a partnership between ABS Television and the Ministry of Education. Thank you for viewing this lesson. Join us again next time.